Hi, what is the value of p? Given that you have 2 to the power of p multiplied by 2 to the power of p multiplied by 2 to the power of e, p equals minus 8. Then let's have it to be solution. So from here we have here to be 2 to the power of p plus p plus p to be equals minus 8. So we have here to 2 to the power of p plus p plus p will give us 3p equals minus 8. Remember, when you have a to the power of m n, this can be simplified as a to the power of m, all in parentheses, to the power of n, or equals a to the power of n, all in parentheses, to the power of m. So when we apply it here, we can have this as 2 to the power of p, all in parentheses, to the power of 3 equals minus 8. So we have here to be 2 to the power of p to the power of 3. Let's take 8 to be here, will be plus 8. Then let's set everything to be equal 0. Let's have 8 in base 2. So let's write this as 2 to the power of p, all in parentheses, to the power of 3, plus 2 to the power of 3 equals 0. This sum of 2 keep. When you have a to the power of 3 plus b to the power of 3 equals a plus b, all in parentheses, multiplied by a square minus ab plus b square as this. So from here, we are going to have our a to be equals 2 to the power of p and our b to be equals 2. So when we substitute it here, we are going to have here to be 2 to the power of p plus 2 as this in brackets again. A square will now be this 2 to the power of p square, then minus a is 2 to the power of p, b is 2. So here will be 2 multiplied by 2 to the power of p as this. Then from here you have this plus b square will be 2 square. We have here to be 4. We set everything to be equal 0. So from here, what are we saying is that for this particular expression to be equal 0, is either we have 2 to the power of p plus 2 to be equal 0, or we have 2 to the power of p, all in parentheses, to the power of 2 minus 2 multiplied by 2 to the power of p plus 4 to be equal 0, for this expression to be equal 0. So from here, we have 2 to the power of p equals minus 2. Now, for any value of p such that p greater than 0, here will always be positive, while here is negative. So for this reason, this we can reject this one, and it will not have, or it implies that we have no resolution. But we can have a complex solution of this because we believe that 2 to the power of p equals, we can simplify this as 2 times minus 1, but in a complex space, I to the power of 2 equals minus 1 as this. So therefore, from here, we're going to have 2 to the power of p equals 2 multiplied by I to the power of 2. So from here, we can obtain the complex solution. So we are going to introduce log 2 to the power of p equals log 2i to the power of 2. So when you have log a to the power of n, this power n will come down to the base as m multiplied by log a. So here will be p multiplied by log 2 equals log of 2i to the power of 2. This I symbolizes the fact that it's a complex number. So we divide by log 2. This and this will cancel. So we're going to have p equals log of 2i to the power of 2 divided by log of 2. Then let us also recall that when you have log a divided by log b, this can be simplified as log of a in base of b. So when you apply it here, we are going to have this, our p, the value of p, to be equals log 2i to the power of 2 in base 2 as this. That's for the case 1. Let's go along with case 2. So for case 2, where we have 2 to the power of p, all in parentheses, to the power of 2 minus 2 multiplied by 2 to the power of p, all in parentheses, plus 4 equals 0. We can solve this using quadratic formula, where we are going to have 2 to the power of p equals minus b, positive or negative, square root of b square minus 4ac, all divided by 2a. So from here, the parameter a is the coefficient of 2p square, which is 1, while parameter b is the coefficient of 2 to the power of p, which is minus 2, while the parameter c is the constant of expression, which is 4, or constant of quadratic. So from here we have this to be 2 to the power of p equals minus 2 here will be plus 2, positive or negative, root of this will be 4 minus 4 times 1 times c, that's 16, then all divided by 2 times 1. So 2 to the power of p will be equals 2, positive or negative, root of 4 minus 16 will give us minus 12 divided by 2. So from here we have 2 to the power of p equals 2, positive or negative. We can have this as 3 times 4 times minus 1, all divided by 2. This 3 times 4 will give us 12. Multiplied by minus 1 will give us minus 12 as this. Then let us recall that when you have root of a times b times c equals root of a times root of b times root of c, when you apply it here, we are going to have 2 to the power of p equals 2, positive or negative, root of 4 times root of 3 times root of minus 1, all divided by 2. So from here we have 2 to the power of p equals 2, positive or negative, root 4 will give us 2, multiplied by root 3, root of minus 1 will give you I in a complex number. Then all divided by 2. So from here, you have 2 to the power of p equals, this 2 divided by this, we have 1, positive or negative. This 2 divided by this one, we have only root 3i. Then from here, it is true that we have 2 to the power of p to be equals 1 plus root 3i as the first one, and 2 to the power of p equals 1 minus root 3i. So we reject this, because for p greater than 0, here will be positive and here is negative. So we reject this one. But if we are to go along with this one, we can solve this one. We are going to have log 2 to the power of p equals log 1 plus root 3i. So this power will come down to the base as p log 2 equals log of 1 plus root 3i. When we divide by log 2, this and this will cancel. So we are going to have p to be equals log of 1 plus root 3i in base 2. Yes, another solution. We also have p equals log of 2i to the power of 2 in base 2 as another solution in a complex space. This is a complex solution. We don't have a real solution. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. Bye-bye.